All right, so just a quick review here of what we talked about on Friday in regards to acceleration. Okay, this is the formula that we were working on using. Okay, where acceleration, which is a vector quantity, is final velocity minus initial velocity divided by time. Okay, we've gone over the 4 different manipulations of that. Okay, and then we put this question up, but I don't think anyone even got a chance to really start it, did they? Okay. All right. So what we're going to look at then is I'm going to give you a few more minutes to try this one, but here's the tips on this one. Is acceleration a vector quantity? Can it be negative? Okay. And in this case, I've got a ball rolled up a hill, initially at least, up a hill. But if you roll something up a hill, eventually, what's it going to do? Yeah, eventually it's going to come back unless it rolls off the top of the hill, but then it rolls down the other side. So either way, it's going to end up going down the hill. You get my drift. This hill isn't long enough, or is long enough so that it'll come back toward me. Okay, so we've got in this one here, okay, we want to write down our givens, okay, and then manipulate the formula and solve. All right, so I'm going to give you a couple minutes on that before I walk through it with you. Okay, so first thing, as always, guys, we want to write down what the question gives us. So it says the ball is rolled up a hill at 4.5 meters per second. So that's going to be my initial velocity. And I'm going to make up the hill positive. Okay, because that kind of just makes sense to me. Up should be positive. All right, it accelerates down the hill at 2.1 meters per second squared. So that means 2.1 needs to be negative. All right, what is the final velocity after? So we're looking for VF, 3.5 seconds. All right, so this is the formula we're going to use because it's got all of that stuff in it. Okay, and we're solving for VF. So what should I move first? T, right, I want to move what's not attached first. So I'm going to multiply both sides by T. What am I going to do with VI? Add it, yeah, okay. Remember, guys, we talked about this last week when we said T times A equals the change in velocity. So if I want to find my final velocity, I add my initial to the change. If I want to find the initial, I take my final and subtract the change. Okay. All right, so I'm going to have VI plus T times A equals VF. All right, now I just need to plug in my numbers. So VI, we said, was positive 4.5 plus 3.5 seconds times negative 2.1 meters per second squared. Okay. So 4.5 plus 3.5 times negative 2.1. So it's going to be moving up or down? Yeah, it should be moving down the hill. Okay, and again, we always want to kind of make that estimate or kind of prediction before we actually do it, right? And the reason I say that is because if every second it's going to accelerate downwards at 2.1, and it's accelerating for 3.5 seconds, that's like a change of 7 meters per second, agreed? Or actually a little more than 7 meters per second. Well, I was only going 4.5 to start with, so my prediction is that it should definitely be moving downhill, okay, which it is. All right, so it's moving down the hill at 2.85 meters per second. Now here's one of the tricks. Mathematically, this comes out to negative 2.85 meters per second. What do we need to write it as? Nope, not an acceleration. We need to say not down, downhill. I know that seems really anal, and it is, okay? But that's physics. Down and downhill are different. Down is straight down. Downhill is angled somewhat, okay? And negative is not what I was given in the question. It's what I got mathematically. But remember, I said when I was writing the givens, I'm going to make uphill positive and downhill negative. That means when I'm done, I need to write out that this is 2.85 meters per second downhill. Okay? And that's something that trips up even my physics 20 students still. Okay? We have a question about a ramp, and they write at the end that it's up. So the thing magically flew off the ramp straight vertically upwards is what they said to me in their answer. Okay? Which is not what happens when something rolls up a ramp. Agreed? Okay, so just, what's that? Uphill or up ramp or 30 degrees above the horizontal, whatever the angle of the hill is. There's any number of things other than up. Up is by definition straight up, okay, as is down. Everybody follow there? I know It seems really, really picky. It is. That's physics. Okay? We're detail oriented. All right, so can you use that? No, it won't work for this formula. Okay, it just absolutely won't work for this formula. Okay, so you're done with those. If you were still using them, shame on you, but you're done with them now because you can't use them anymore. Okay, all right, write this one down and give it a try. Okay, so from walking around, it looks like we're still a little bit, we need a little bit more practice with the manipulation, that's what today is all about anyway. So let's have a look at what our givens are first in this one. So an object is thrown up, so that's vertically up, straight up in the air at an unknown velocity. All right, that means VI is, sorry, not zero, but a question mark. We don't know what it is. Okay, it's in the air for 6.5 seconds. Okay, and its final velocity is 2.4 meters per second down. Right, I'm going to make down negative. I always make down negative. All right, acceleration due to gravity is 9.81 meters per second squared down. All right, so acceleration is negative 9.81 meters per second squared. All right, so I have everything except VI. So the formula is going to be A equals VF minus VI over T. I mean, yes, you could draw the arrows on there, but it doesn't really make that much difference. Okay, so I'm solving for VI this time. Same rules apply. I still want to move T first because it's not attached to any of these things. So I'm going to multiply both sides by T. All right, so we got T times A over here equals the change in velocity. So rather than solve for VI when it's negative, I'm going to bring VI over to this side by adding it. Right. So I got VI plus T times A equals VF. Okay, I know we're looking for VI, but we'll get there. All right, so right now we have VI plus T times A equals VF. Now, if I was doing order of operations, okay, in math, I would multiply T times A before I added it to VI, agreed? So is T times A really just one number? Yes. So can I move it over to this side together? By doing what? By subtracting it, right? Doing the opposite. I'm adding it here, so I'm going to subtract it. That's going to mean VI equals VF minus T times A. Okay, here's the other way we can think about that. When we first started that manipulation, we had T times A equals VF minus VI. So in other words, T times A equals the change in velocity. All right, so if I take my final velocity and subtract how much it changed by, that should leave me with VI. Agreed? In the same way that if I take VI and add the change, I should get VF. All right, that's kind of the logic behind that movement. Question 10? You got to move stuff around before you get to that. That's what I did. Because then VI ends up being negative. And I don't want to solve for VI when it's negative because I always forget it's negative and then I get the answer wrong because I have the wrong vector. Does that make sense? Okay. All right, so I've got this set up now. Now I just need to plug in my numbers. They told us VF was negative 2.4. Actually, they said it was 2.4 meters per second down. Okay, minus our time, which was 6.5 seconds, times negative 9.81 meters per second squared. So I've got a negative, and I'm going to be subtracting a negative. Agreed? So that's going to make it very, very positive, which makes sense because it did say it was thrown up. Okay, so our prediction there should hold true. Okay, so VI is going to equal, all right, so we got negative 2.4, okay, minus 6.5 times negative 9.81. All right, so it's saying that the initial velocity of the object was 61.37 meters per second up. Yeah, for now, for 2 decimal places for now. Yeah, okay, will be good enough. Okay, now something I also want to caution you about because sometimes people end up doing this. Okay, Like on our last question here, where our answer was down, okay, or downhill, sometimes people leave the negative on here. Okay, is that answer right anymore? Why is it wrong now? Negative downhill is uphill, right? Okay, so watch what you write, because negative up is down. Negative down is up. Are you confused yet? Good. Okay. Okay, just keep that in mind. Vectors, okay, can be weird. Yeah, but no one would ever write it that way. Okay, but positive doesn't change the direction, right? So that would be okay. Weird, but okay, right? Positive uphill is okay, right? Positive downhill is also still downhill, but when you put the negative, then it reverses it, right? So just write the vector. That's your best bet, okay? Write the actual vector. Okay. All right, so what I'm going to have you guys do here, I'm going to walk through this one with you first, and then we're going to work on just some ones from the digital workbook, okay, for a little while just to get some practice, and then you guys can ask questions. We can go over the ones we need to, okay? But there is something on this question that I need to show you, okay, how to do. And that is how to do what's called a compound conversion. That means changing more than one unit at a time. Okay, it's not hard. I just have to show you how to do it because you've never done it before. Okay, so I have a race car that reaches a straightaway on the racetrack going 140 kilometers per hour and then accelerates at 3.5 meters per second squared for 6.2 seconds. What's the problem here? Right, one's in kilometers per hour, and then I've got an acceleration in meters per second squared and a time in seconds. Okay, I'm going to have to do some converting here. And the most logical thing to do is to convert the kilometers per hour to meters per second, okay? Because otherwise I've got to change two other numbers, okay? And then I'm going to get weird answers, like 6.2 seconds. It's like a very small fraction of an hour, right? And it's going to make a really weird answer, okay? So we're going to convert the 140 kilometers per hour. So how many units do I have to convert there? 2. I've got to convert the kilometers to meters and the hours to seconds, which isn't hard. Okay, so here's how we do that. Okay, we have 140 kilometers per hour. Okay, written like that, kind of like a fraction. If I want to convert the kilometers into meters, what do I have to multiply by? 1,000. Kilo means 1,000. That's the beauty of the metric system. It doesn't matter whether it's grams or meters or liters. Kilo is 1,000. Okay, so I'm going to multiply by 1,000 meters per kilometer, right? That's the conversion factor. In 1 kilometer, there are 1,000 meters. Now, I got kilometers on the top and kilometers on the bottom, so what happens? They cancel off. All right, so as long as I multiply the 140 by 1,000, I have meters. All right, so that converts my meters. Now what do I do with the hours? I got to convert it to seconds, right? So I've got hours on the bottom. Where do hours need to be if I'm going to convert it and get rid of hours? On the top. Okay, so in 1 hour, there are how many seconds? Everybody wants to say 60. It's a gut reaction, but that's how many there are in a minute. 60 times 60 is 3,600, right? There's 3,600 seconds in 1 hour. I love that. It always happens whenever I ask that the first time. How many seconds in an hour? 60. It's just, we just want to do it. We know it's wrong, but we do it anyway. Okay, so I got it. Hours on the bottom, hours on the top. So my hours are gone. Sorry, and this is seconds. Okay, so now if I multiply 140 by 1,000 and then divide by 3,600, I'll get meters per second. Everybody okay with that? That's cumbersome, isn't it? Okay, it's kind of cumbersome. So what I'm going to do is I'm going to pull these two fractions together. Okay, because I got these two parts canceled anyway, and I'm multiplying them. So really, what I'm saying is 140 times 1,000 over 3,600. Okay, well, there's an even quicker way to do this. Can I divide both of these numbers by 1,000? Yes, so then that's going to mean 140 times 1 over 3.6. What's 140 times 1? Okay, so could I just go 140 over 3.6? Write that on your formula sheet. To convert kilometers per hour to meters per second, divide by 3.6. To go the other way, multiply by 3.6. Kilometers per hour to meters per second, yes. And meters per second to kilometers per hour. Okay, but that's what we do. That's a compound conversion. Okay, that's how you would convert any unit that had two things that you had to convert. You just kind of write them out in a line and then push them together. Okay, so on your formula sheet, just write kilometers per hour to, like put an arrow to meters per second, divide by 3.6. And then you could write meters per second to kilometers per hour, multiply by 3.6, okay, just so you have it on there. And that you can keep on there. I won't even make you erase that or give you a new formula sheet on the test if you have that written on there, because I just told you to write it on there. Okay, so that's our first part of this question then, because the first part of the question wants to know what's the car's initial velocity in meters per second, which means take the 140 and divide by 3.6 to convert it. Whoop. All right, so we got 38.89, we'll say. Okay. I know I rounded it here, but 38.9 meters per second. All right, so we have VF, or sorry, we have VI, we have A, and we have T. So can we find the car's final velocity? Okay, I'm going to give you a minute or two to try that one on your own, and then we'll walk through it. All right, so we got this, we know what the initial velocity is now, so we know VI is 38.9, okay, and we know that the car, we're looking for VF. Sorry, I keep writing 0, don't know what it is, okay. We know the acceleration is 3.5 meters per second squared. Right? And we know that the time is 6.2 seconds. We can only assume that this is all forward because we're not told otherwise, right? It says it hits a straightaway. It's not like you come off of a corner in a race and jam it in reverse. Okay, we kind of have to go with the context of the question. Okay, transmissions generally don't like going from 140 kilometers per hour forward to reverse. They tend to destroy themselves. Don't try that, by the way, if you have a manual. Yeah, all right. Okay, so I'm looking for VF. Okay, so I got VF minus VI over T, and I'm solving for VF. So I'm going to multiply both sides by T, and then I'm going to add VI over to this side. So now I've got my formula. I just need to plug in my numbers. 38.9 plus 6.2 seconds times 3.5 meters per second squared. Okay, and I should get 60.6 meters per second. Okay. Everybody all right with that? I don't have to put forwards because I wasn't given that in the question. Here's the weird thing about acceleration. In this question, I was given speeds. Right? Acceleration is a vector quantity that can work with speeds because speeds can still produce a negative acceleration. So in this case, because I wasn't actually given any vectors, I don't have to reflect any vectors in my answer. I found a scalar quantity as a result of this. Okay, everybody all right with that? Happens not very often. Okay, this would be one of the major exceptions to the rule. Okay, when you're plugging it into your calculator, are you going, so 38.9 plus 6.2 times 3.5? You sure you don't have an adder or something in there by accident? It's usually something simple. Yeah. So yeah, it's always something simple. I probably wouldn't mark it wrong in this case because again, this is a pretty rare circumstance where you wouldn't have a vector initially anyway. Okay, a couple of things to watch for when you're reading through acceleration problems. Okay, you might want to make a couple notes of this somewhere, probably not on your formula sheet. Okay, if I drop something, how fast is it going initially? Right. Okay. If I drop something, its initial velocity is 0 because the second I let go, or the instant I let go of this, nothing has happened yet. That's time 0. Right. Now, when I drop something, it's going to fall. Agreed? Unless something really, really strange happens. Okay. It's going to fall. At what rate? Right, it's going to accelerate at 9.81 meters per second squared. So sometimes a question won't outright give you those numbers, right? It'll say like somebody dropped something off a roof, okay? And then it says, after 2 seconds, find out how fast it's going. So it seems like the question only gives you one number, but really it gives you 3. It told you it was dropped, so you know VI is 0. And because it was dropped off of a roof where you can only assume roofs only exist on Earth, okay, then we would assume it's 9.81 meters per second squared for the acceleration. Okay, so sometimes it might seem like a question doesn't give you a lot of info, but it does. Okay, you have to read the context of the question sometimes. Okay, Jacob, question. It should be on there. It should say G equals 9.81 meters per second squared on there somewhere. Yeah. Tanner? No, everything falls at exactly the same speed. Okay? Like we're saying, in the perfect physical world. Okay? Perfect physical world where air resistance isn't a factor, all things fall at the same rate. I'm actually going to show you a video about that. Okay, so this is a question that has to do with a particle accelerator, okay, like the LHC, okay, the Large Hadron Collider, okay, things like that, where they just smush particles together to make really big ones, right? So in order to do that, they use like magnetic fields and things like that to accelerate these charged particles to incredible speeds, okay? Like this speed here, 2.5 times 10 to the 8, right? To give you an idea, the speed of light is 3.0 times 10 to the 8. Okay, so this is relativistic, right? It's it's getting close to a percentage of the speed of light. So what we want to do here is calculate how long it takes. So we're looking for time. How long does it take to accelerate the proton from rest? Okay, so from rest is what? Okay, so VI is 0. Okay, VF is 2.5 times 10 to the 8 meters per second. Right? And we know that the acceleration is 800 meters per second squared. Okay, so we have A equals VF minus VI over T, and we're solving for time. All right, so we're just basically going to switch T and A. Okay, so we have that. So we'll have 2.5 times 10 to the 8 minus 0 over 800. Okay, that's what we're going to have to plug in. Now, in case you've forgotten how to plug in an exponential or scientific notation number, okay, we use brackets, 2.5, and then we hit the second function button, and we hit the comma, because there's 2 little e's above it. Okay, that gives us the e, which means times 10, right? And this is times 10 to the power of 8. Right, then I just close off the brackets. Do I need to write minus 0? No, I can just divide this now by 800. All right, so it's going to take 312,500 seconds. That seemed like a long time. It's how much? 86 hours. Right? Now, I mean, in a particle accelerator, it's like a circle, right? They accelerate them in this circle for a long time before they smash them together, and because it takes quite a while to get them going. Yes. Oh, okay. So we would go. So here's where the decimal is in this number right here, right? With me there? Okay, so I'm going to move it 1, 2, 3, 4, 5 places. Right? Scientific notation is always a number between 1.0 and 9.9. Okay, so I'm going to make this 125, sorry, times 10 to the, I moved it 5 places, 10 to the 5 seconds. All right with that? Okay. If I want to put something in scientific notation, I move the decimal until I have it so that the number is between 1 and 9.9. And then I just count how many spots I move the decimal. That's the exponent I put on the 5. Yep. I know I'm kind of off and on the rounding here. Let's say 2 decimal places. Okay, and we'll be good enough for that. Yeah, so I round it off differently. Yeah, when I'm making up the key, sometimes I'm just trying to stay ahead of the people doing it, and so I'm kind of in a rush. Sometimes I not very careful. That's why sometimes there's mistakes. Number 3? Yeah. All right, so on number 3, we have this fighter jet that's accelerating, and here's its acceleration. So they told us that, okay, 11.1 meters per second squared. Right? Its VF is 35 meters per second, and its VI is 22 meters per second. And we're looking for how long in seconds that's going to take. So it's the same calculation we just did. So A equals VF minus VI over T. So we multiply both sides by T, okay, divide both sides by A, and we've got our number. So T will equal 35 minus 22 meters per second divided by 11.1 meters per second squared. And when we do that, we should get 1.17 seconds. All right. Does that make sense? Yeah. Having trouble in the calculator? Top's got to be in brackets. Okay, when I punch this into my calculator, if I go 35 minus 22 and then divide by 11.1, my calculator divides 22 by 11.1 and then subtracts that from 35. Okay, I want the top to be in brackets, okay, so that it does that first. So I actually have to do that. 35 minus 22, okay, in brackets divided by 11.1, and I get a much different answer. Okay. Any other ones giving us trouble so far? That's as far as you got. Okay, well, I'll give you a chance to get ahead of me again then. All right, so for number 6 here, okay, we've got a ball that rolls up a hill towards the hole, okay? So if it starts with a velocity of 2 meters per second, that would be up the hill, and accelerates at a constant rate of negative 0.5, so that would be down the hill, okay? What's its velocity after 2 seconds? All right, so I know VI is positive 2.0 meters per second, and I'm looking for VF. Okay, I know that the time is 2 seconds, and I know that the acceleration is negative 0.5 meters per second squared. So A equals VF minus VI over T, and I'm looking for VF, so I'm going to multiply both sides by T, and then add VI over here. Okay, that'll give me VF. So VI we said was positive 2, okay, plus the 2.0, okay, times negative 0.5. Everybody follow there? So after 2 seconds, if you're losing half a meter per second, you're going to lose 1, right? So if we punch this into the calculator, okay, not that we need to, but okay, if we punch it in, we go 2 plus 2 times negative 0.5, right, we're going to get 1 meter per second uphill, right? Now, I did change that on the sheet. That now says uphill on the sheet instead of positive, okay? And if it occurs for 6 seconds, what's the final velocity? Well, it's the same formula. What do we do with this 2? Change it to a 6. Yeah, it's just exactly the same formula. It's just now how long will, or how fast will be going after 6 seconds. Okay, if we do that, then okay, we got 2 plus 6 times negative 0.5. Right, so we're going to get negative 1. No, in a part 1 and a part B, if it was like, I don't think I would ever give you the same calculation twice in an A and a B. Right, yeah. Yeah, that would be downhill. And that's what it says on the key now. I changed it. No, no negative, because negative downhill is uphill. We talked about that earlier, right? Okay. Okay, so like I say, I've changed those now so that they say uphill and downhill on the key. Okay, so question here for number 16. Okay, we got a particle that's moving with an initial velocity of positive 112. So we were told VI there, positive 112 meters per second at time 0 seconds. So that's VI. Okay, the particle has no acceleration until time 3 seconds. So if it's not accelerating, what is it doing? No, it's moving at a constant speed of 112 meters per second. Okay, everybody follow me there? So we got to have like a kind of a part 1 here. Okay, so it is actually just going to be V, not V average, right? and that time goes till 3 seconds, after which it accelerates at -4 meters per second squared. What's the velocity at time 16 seconds? Okay, so rather than write part 1, I'm going to go back to this being VI. What do I have to understand about the length of time this acceleration occurs over? Is it 16 seconds? No, 13. Right, it's 13 seconds because we start at time 0, we end at time 16, but we only accelerate between 3 and 16 seconds. It's just a question to make sure you're reading carefully. And that's the lesson of this. It's not that this is difficult mathematically. The lesson of this question is read the question carefully so we understand the context in which the question occurs. Okay, so time is 13 seconds on this one. Okay, we're looking for VF. We don't know what it is. And we're told that the acceleration is -4.0 meters per second squared. So A equals VF minus VI over T. We multiply both sides by T. Add VI to both sides, we've got VF, so we'll take our 112 plus 13 seconds times -4, and that'll give us our final velocity, so 112 plus 13 times -4, right, gives us 60 meters per second. And that's positive because we were given positive and negative in the question. Okay, always be on the lookout for dirty tricks like that. Any others giving us trouble? Okay, keep going then.